Hello. Hi, everyone. I hope I am live now. So, a very good evening to all. Uh, I can see many people have joined us. So, those who are with me in the live session, can you guys just give me a quick confirmation? Am I clearly audible to everyone? Is my voice is clear, perfectly audible? Those who are listening me live, we will start our discussion very soon. But in the meantime, it would be great if I get a quick confirmation from you, from your end. Am I audible to everyone? Can I get a quick confirmation maybe in the chat window? Is my voice is clear, perfectly audible to each and everyone? And in the meantime, I also check at my end how's the things going on. Yes, the voice is clear. Okay, I started getting the confirmation. Thank you so much for that. Maybe just try to share this information with everyone that today we are having episode number 9 in our AI engineering playlist. So it's a live session. So please tell everyone to join over here. And we will take all the doubts also in the live mode. So it will be a very interesting class. Okay. So till so far in our previous discussions अगर आप लोगों ने AI इंजीनियरिंग का प्लेलिस्ट पूरा फॉलो किया है तो यू मस्ट हैव ऑब्जर्व कि हमने अभी तक AI एजेंट्स के बारे में पढ़ा, हमने अभी तक रैग बेस्ड एप्लीकेशंस के बारे में डिस्कस किया, वी हैव आल्सो डिस्कस्ड अबाउट कि कैसे लैंग ग्राफ लैंग चेन फ्रेमवर्क्स हमारी हेल्प करते हैं टू बिल्ड द प्रोजेक्ट्स. Today, I'm not alone. I'm with my learner, and he has built one very interesting project, NovaAssist project. He has built, where he will showcase you how he has used the RAG framework, how he has used multiple agents to do the task. देखो मल्टीपल एजेंट्स यूज करना ऐसा नहीं कि कंपलसरी है, ऐसा नहीं कि एक एजेंट सारे काम नहीं कर सकता, बट if we provide the power of working different things to different agents, that is where we can make our overall product more scalable. At the end of the day, I hope you all agree with me, that is what company requires from us, that is what companies expect from us, right? अगर मैं एक अपने क्वेरी में डाल रही हूँ that generate the python code, एक में डाल रही हूँ can you just let me know what is the weather in Delhi, और एक में डाल रही हूँ कि can you just help me to summarize this PDF. So I know that for all these three questions, ideally there should be three different agents sitting, because these things are independent of each other and they require a dedicated effort. So today we will learn ki how we can create a pipeline which will help us to build end-to-end product, which will help us to build multiple agents in one go. And this is what is built by one of my learner, Himakesh. So I just welcome him first. Hi Himakesh, how are you?
Hi, ma'am. I'm great. How are you?
Nice. So I think we can proceed further, and now we can talk about what exactly we have built in this project. But before we will talk about further the project part and its core detail, I want you to introduce yourself to everyone. I think you already have come previously also in my YouTube live. So maybe first of all, you can give a brief intro and then maybe we can proceed further.
Sure. So, hello, everyone, and thank you for joining us again. So, my name is Himakesh Krishna, and I did my PG certification in data science from IIT Guwahati. And some of you may have joined the previous session where I presented my BBC classification project. For those who are new, I come from a biology background and completed my bachelor's in geology honors before transitioning into data science. And in my previous presentation, we explored NLP, or natural language processing and machine learning, in which I have explained and demonstrate a project which is called BBC News Classifier. Today, I would like to take a step further and showcase a project that focuses on agentic AI and multi-agent system instead of building a single AI chatbot. So here we have six agent which are orchestrating together. And then in this project, we will demonstrate how multiple specialized AI agent can collaborate, do the reasoning, retrieve information, and generate a unified response to solve customer support queries. And one more thing, by the end of this live session, I will make sure that you will have the revision of all the lectures in this specific AI engineering series playlist of Priya ma'am. And you also have the intuition that how actually the enterprise level or industry level agentic AI architecture were made. So I'm really excited to walk you through both the architecture and the engineering decision behind the system. So I believe we should start now.
Perfect. Yeah, I think we can start now. And I'm sharing your screen, Himakesh. Now your screen is perfectly visible. Maybe, if possible, you can expand your screen a bit. Uh, Architecture is ARCHI. Architecture.
Yeah. So
Perfect. Now we can proceed. Yeah.
before we move to the architecture, I will give you the bit of introduction to the front end. So this is how actually the front end looks, and by the end of this lecture, you will have a intuition that how actually these things are actually working. So now we move towards the architecture. So let's say I user have a query mm, on the support agent that hello support. So this will go to the browser chat UI where I built the UI using HTML, CSS, and JavaScript. And in the backend, I have used the fast API server, which is connected to the SQLite server database. And I'm also storing all the LangGraph state in this SQL server. And after this response, it will get to the planner agent node, which will assign agents and pending state. And then that particular message will be routed to the router edge node. So the function of router edge node is just to route it to the specific agent according to the query. So if the router agent thinks that this query might needs retrieval, then it will route it to the retrieval agent. And if it thinks that it should be routed to the support, then it will route it to the support agent. And at the end, if escalation is needed, then it will route it to the escalation agent, right? So as you can see, the retrieval agent node where we have implemented a RAG agent, it is actually connected to the Quadrant Cloud DB. So Quadrant is a vector database where we are storing our vector embeddings and all the Novatech policies over here. And then using the agentic RAG, we are going to retrieve this information whenever needed by the user. And then at the end, when the work of retrieval agent, support agent, and escalation agent will be finished, then it will be routed to the synthesizer node. Then synthesizer node will get the state of message from all these agents, and then it will synthesize the final response. And then at the end, we will have the response. So this is how the architecture will look. Now I will show you the code demonstration in the VS Code. So first of all, we are going to import all the libraries which are required for this architecture. So I have imported all the queries here, and then I have configured all the APIs. By the way, I'm using Grok for the LLM response, for generating the LLM response over here. So Grok is basically a free LLM platform, which you can also use in your projects too. And one more thing that I have also implemented a fallback in this particular architecture. At the end, I will explain you that how and why we actually implement the fallback into our projects, and how it is very useful in the project, and even in the industry we use the fallback too. So here I have imported all the API keys through the .env file, and then I also show you the documents we have in this particular NovaTech. So we have facts, some internal documents, some outdated documents, and some policies, as well as some technical documents. So we are going to build a vector database using these documents. And here I have extracted all the documents using the document extraction pipeline. So here, as you can see, we found 7 valid document, and I have uh, grab all the documents from the directory, and then I did the chunking. So for the chunking part, I will explain you everything that how actually chunking is working. So here we are using the recursive character splitter to do the chunking. So we are assigning the chunk size to the 1000 and chunk overlap to 2000. So basically that every chunk will have some characters, right? So let's say there is chunk 0 and chunk 1. Then let's say if chunk 0 has 1000 character, then in chunk 1, the last 2000 character will be also present in the chunk 1. And then we are using the to measure the chunk size, we are using the length function over here. So as we know that we have multiple documents in this NovaTech. So we have, for example, I'm saying that we might have shipping policy, refund policy, warranty policy, and privacy policy. So these might have a chunk ID which is 1, 2, 3, 4. So this is what I have did here too. So as you can see, I have given the chunk size as 1000 and overlap 200, and as length function, I'm using the length function to measure the chunk size. And here I'm looping through every document we have to create the chunk. And we will skip any unreadable file, uh, which is either not be .pdf, .docs, or anything. And then we are appending all the characters into the raw text. We also have metadata in this chunk. So metadata is very important. So metadata is basically data about the data, which will be useful in retrieving the chunks too. So here, as you can see, we have all the chunks that we have created using all those documents. I believe we are using 7 valid documents, right? So we are using 7 documents, and 10 chunks were generated using these 7 documents. Now we talk about how we actually embedding these chunks into the quadrant vector database. So, so embedding, we all know, you might have already visited to the Priya ma'am's playlist, and as we know that computer doesn't understand English language, that's why we use the embeddings to convert those English languages into the numbers, right? So let's say we have an example, I love dog. This will be converted into these embeddings. So here we can use a multiple vector sizes. Here I'm using 3072, but we have multiple vector embeddings. So we have 384, 768, 1024, 1536, and 3072. So for different model, we choose different sizes. Here I'm using the Gemini embedding 001 for embedding. So you might don't know that where do this number come from. So let's say we have a sentence, I love dogs. This will first get tokenized, and uh, each character will be splitted. I mean, each word will be splitted, and it will be assigned a token ID. So we have a token ID for I, love, and dogs, and then it will go to the neural network, and then they will get trained. And finally, we have a vector embeddings of like 3072 embedding size. So, for example, we have this vector embeddings. So how does actually one sentence become one vector? So we have multiple methods you are doing converting one sentences to into one vector. So we have CLS token bird, which is basically a special CLS token is added at the beginning of every token. We also have mean pooling, which is very common. In this, we actually take the vector embeddings of all the characters or words, and then we uh, took the average of all the embeddings. And in the max pooling, we took the max of all the embeddings for the sentence, right? And then why are similar sentence close together? So similar sentence embedding becomes closer, and different sentences embeddings move farther. So how this happens actually? For example, we are taking only here 2D vector, for example. So let's say dogs are cute. So all of them are assigned by a 2D vectors over here. So as you can see, that dog or quit are assigned as 2 comma 3. I love puppies assigned as 2.3 comma 2.9, and cats are wonderful also assigned as 1.8 and 3.2. But as you can see that Bitcoin crashed is assigned as -6 and 9. So if you do the visual representation, you can see in the vector 2D space that cats, dogs, and puppies are very close to each other, but Bitcoin is very far in the representation. So this is how similar sentences come together into the vector spaces, and different sentences move farther. So this is actually how things are working in the backend. Now we will talk about the retrieval part.
So I hope that over here, the way he's explaining and the code implementation, the way he's talking about and the concept as well, I think he's doing in a very good way. It should be quite easily understandable. Plus, those who are already followed my previous episodes, specifically whatever till so far he has explained regarding RAG. How many of you have watched that entire discussion of RAG? As far as I know, this was episode number रैग हमने कौन से एपिसोड में कवर अप किया था एआई इंजीनियरिंग प्लेलिस्ट के अंदर लेट मी चेक इट
Probably
इज
6 or 7.
अंडर हाँ एपिसोड नंबर 5 एंड 6 या
Okay.
5 6 में हमने कवर अप किया था सो इफ यू हैव ऑलरेडी गोन थ्रू विद दैट तो ये सेशन आपके लिए बहुत इंटरेस्टिंग और बहुत इजीली अंडरस्टैंडेबल होने वाला है because the way he has done the implementation, it's quite similar to the way I have showcased in those discussions as well. And the concepts also, you will be able to revisit all the concepts that we have covered up from episode number 1 till episode number 8 in this one project. So just listen the session very carefully, and the good thing is he's explaining even to the people who maybe have missed the session previously. For example, there is no need as such to explain about the semantics and what is the vector and how they are working internally, but still he has explained the reason being ki if there is someone who is maybe directly jumping today and joining us live, they will also able to get the context of this discussion whatever we are doing. So impressive discussion, but one thing I want you guys to be consistent, listening it very carefully, and if you have any questions you can side by side post it in the chat window. Also, we will have a live session now. If you guys want to join us live in the cohort also, You can check out the course at my platform Tech for All with Priya. We are launching the course very soon. We will start our session. I have already launched 8th August ko we will start our very first class. So if there is anyone who is interested to learn like this, where we will build the projects in a live way, please do check it out. Description में आपको course का link भी मिल जाएगा. Now I think we can proceed further, Himakesh. Yeah.
Sure. Now we move towards the retrieval part, right? So here we are going to retrieve the document. So, so let's say customer asks that what is the refund policy? Then this specific sentence will be first converted into embeddings. So let's suppose that this is marked as or labeled as embedding Q. So this particular sentence converted into this embedding, for example. Now the vector database compares embedding Q against every stored embeddings in the database. For your context, I will show you that how actually the embedding looks like. So here, as you can see, there are points being created into the quadrant vector database. So here we have multiple points, and these embeddings will be compared to all these points or chunks. And then as I can see as I can say, for example, let's say that chunk 1, chunk 2, chunk 3, chunk 4 have a respective policies as mentioned here. And as you can see that since the user have asked about the refund policy, then it must retrieve only the refund policy, right? So here you can see the embeddings of all the policies over here. So for chunk 1, it has this respective embeddings. So if you see closely, that embedding Q have 0.55 comma 0.20 comma minus 0.29, and it is very close to 0.53 comma 0.18 comma minus 0.27. So after matching this embedding Q with all the chunks, it will say that this is a strong match from chunk 2. Then this will return. So for example, in chunk 2, there is a message which says that return merchandise is accepted within 30 days. So this is actually the stored sentence in this specific chunks as an embedding. And system doesn't only retrieve one chunk, it actually retrieve the top k chunks. For your knowledge, I'm saying that I'm retrieving the top three k's over here, top three chunks over here. So this is how the retrieval actually works. So how actually vector database looks like. So as you can see over here, I've also showed you over here that each sentence has some embeddings like this, and then it also have chunk text, and then it has the metadata, which is data about the data. So this chunk test is present in document which is company policy.pdf, and it has chunk ID 2, and it is present at page number 18 and in the section of refund policy. So this is how things actually work internally. So if you want to compare, you can compare for example, let's say you have a book of 500 pages, and if you wanted to route it to the specific page, instead of looking through or going through every page, you will first go to the index and you will look for whatever specific topic you wanted to study or wanted to have information about. Then you have the data over there about a particular topic that it is present in a specific page number. Then again you will route it to this specific page number, and then you will have that data. This is how actually things are working over here too. So this is how actually retrieval actually work. Now we have built a multi-agent layer which has actually 6 agents: planner agent, routing supervisor, support agent, retrieval agent, escalation agent, and synthesizer agent.
I hope,
So
I mean, before we jump towards these agents discussion, till so far, whatever Himakesh has explained, I mean, about the RAG retrieval part uh, and that indexing part, is that clear to everyone? That embeddings, how they are generating, how we are going to do the work internally? Is it fine for everyone? Shall we move further towards the three, not three, six, I think, right, Himakesh? Six
yes,
different
ma'am.
agents that he has created.
Yes, ma'am.
Can we get a quick confirmation from everyone so that we can proceed further? If you have any doubts, any questions, the idea is to come live is that we can also take your doubts side by side. So if you feel there is any concern you have till so far, or if you want anything, he will repeat again. So please do let him know. Or maybe just give a confirmation to us so that we can proceed further. Can I get a quick confirmation from everybody? Is this all right till so far? Is it fine? Yes, everyone. I hope we are clearly audible to everyone and everybody can easily respond in the chat window. There is no as such issues you guys are facing in terms of listening to us. Okay, now we are getting the response. Yes, so people are saying yes. So I think we can proceed further, Himakesh, now. Yeah.
Yeah. So before we move towards this agent, we have to know that this agent must have brain at what actually they are doing. So for that, we have a specific state, land graph state in this, which I will explain here too. So all these agents are connected to this state. So this is like a centralized brain, and every agents are connected to this brain. And I will try to explain here how actually this state is working. So as you can see in this state, we have substate like message, customer profile. So message will contain the message, customer profile will contain the customer profile. Then in the reasoning, we have the reasoning in the execution, and then we have the execution plan, execution mode, then what are the tasks are completed, then the retrieved context from the RAG agent, and then we have the final response, which will be generated using the synthesizer agent. Then we also have a ticket, which will be generated in case of escalation agent. So let's say user asks a query, my laptop overheats after BIOS update. Is this covered under warranty? If not, I want refund. So this is the basic query that user asks. So now the state will become like in the message. You can see there's a substate which is called message. So in the message, there will be a prompt of the user. My laptop overheats after BIOS update. Is this covered under warranty? If not, I want refund. And here we also have a customer profile, subscription tier standard, and account status active. So by default, if the customer doesn't have any enterprise level or premium level subscription, then it will automatically mark it as standard. And you can also see that reasoning, execution plan, and all the respective substates are empty right now. Now this state will be given to the planner agent, whose work is to assign agents and pending state based on the query the user given. So after having the message and customer profile, the planner agent will do some reasoning, and as you can see that here, it made a reasoning which says that the customer requires warranty information from the knowledge base. First thing, troubleshooting guidance for the overheating issues and refund handling if the issue cannot be resolved. Therefore, retrieval support and escalation agent are required. So this is the reasoning made by the planner agent by having this user response. So as you can see here, the user want the I mean the policies, why actually it's his laptop is heating after the BIOS update, and he also wants to know that if it is covered under the warranty or not. So in the execution plan, that after doing the reasoning, it wanted to route it to the retrieval agent, support agent, and escalation agent. And in the status, you can say all these are pending because it didn't have routed it to the any agent yet. And the execution mode is sequential, since uh, it will route to each agent sequentially or one by one. So now this state will be going through router edge node, and since first, as we see that it is going in the execution plan, it is going to route it to the retrieval agent and then support agent, and then at the end to the escalation agent. So here agent node will route it to the retrieval agent node. We are using the route next function. I will demonstrate this into the code. So in the execution plan, you can see that after uh, this particular state goes to retrieval agent node, it generated some response which says that warranty covers motherboard overheating for 2 years. BIOS version 3.4 has a known overheating issues. So what happens here is that after it wanted the planner node wanted it to go through the retrieval agent. It goes to the retrieval agent, and retrieval agent goes into the quadrant databases and do the semantic search, and then find out what are the required policies to answer the particular query. So we have the retrieved context from the RAG database. Now, after, as you can see that execution plan is completed for the retrieval agent. Now again, the route next will route it to the router node, and then it will again route it to the support agent node, right? So here, the support agent will also write a message that, as you can see, the user has a message that my laptop overheats after BIOS update. So support agent will say that please update to BIOS version 3.5. This issue is covered under warranty, right? Then again, as we know that this, after doing the reasoning, the planner node wanted it to route it to the escalation agent too. So it will route it to the escalation agent too again. So after having all the completed task, in the completed task, you can see that, sorry, first we will see, yeah. So in the escalation agent, it raises the ticket with ticket ID, priority, status, and assigned team, because this particular query wanted to have a human intervention and wanted to have a contact or support with a human. So that's why it routed to the escalation agent and raise a ticket for them. So after completing all the tasks, that retrieval agent, support agent, and escalation agent, and all the tasks are marked as completed, now the router agent again will check a state and see that if all the tasks are completed. And when all the tasks are completed, then it will route it again to the synthesizer node. Then the work of synthesizer agent here is to compile all the responses generated by the mm, retrieval agent, support agent, and escalation agent. Then again, this state will be passed to the synthesizer node, and then with the retrieved context about all the three agents, it will again generate a response. So the final response will look something like this. Hello, the overheating issue after BIOS update 3.4 is known issue and is covered under your warranty. Please update to BIOS version 3.5. Your refund request has also been escalated under ticket XYZ, जो भी है इधर, right? And then we also pop up a ticket ID, and the orchestration will be ended. So this is how actually the state is working over here. So this is the function of state. So you might think that what actually is a state. So state is basically like a whiteboard where all the plan and all the things that are done by all the agents will be written over there, and all the agents can access that particular whiteboard and generate the responses according to the tasks they are given on the whiteboard. So this is how actually things work over here. So after completing the, I think now you have a overview of and have an intuition that how actually this land graph state is working. Now we move towards the planner agent node. As I have already discussed, that planner agents use a user message and decides which specialist should handle it. So this is like a agent that do the planning and reasoning. So we have a prompt over here for this specific agent plan. So we have a planner prompt for this agent, and then it will grab the latest message from the that graph state, and then it has a temperature 0.0 because we don't want any creativity. We just want some reasoning and mm, yeah, and plan execution plan, right? So yeah, so this is it about the planner agent. Now we will discuss about the support agent. The support agent will handle general conversation, queries, greetings, and basic account questions that don't require policy lookup. So we also have so first of all, here as you can see that it will also grab the customer profile from the state, and then we also have a prompt for this. So you are a friendly Novatech support agent. So we have a customer context over here. So this will basically grab the customer profile and then provide a helpful, concise response. Do not invent policies. So these are the system prompt I have given over here. And then this will generate a response. And here the temperature is zero point 0.4 because we wanted the support agent to be a bit warm and supportive. That's why the temperature is a bit more higher as compared to the planner agent. Now we will talk about the retrieval agent. So here retrieval agent is also accessing the user query. So it is accessing the latest message from the graph state, and then it also has a prompt that extract only minimal search query for systematic retrieval. Sorry, semantic retrieval. Return only the search query. Do not explain your reasoning. And then we will enter the user query, and we will have the user query from the state graph state. And here we have the temperature 0 point 0 because we don't want anything the LLM to invent or be creative here over here. We just wanted to this LLM to have the retrieved context from the vector database and reformulate the answers or reformat the retrieved chunks, that is the chunks retrieved from the vector databases. So this is everything about the retrieval agent, and so this will be activated only when the user will ask about the rules, policies, or technical troubleshooting. And this only has the access to vector database. Again, so when the task will be completed of the retrieval agent complete its task, it will append the append the retrieve information, and also it will update the status if it is completed or not, and then it will return all the messages over here. So messages, retrieved context, execution plan, and completed task. Now we will talk about the escalation agent. So this will be activated when the user is angry or try to threaten legal actions or request human manager or human intervention. So, uh, so here we are giving it a customer profile from the graph state, and profile, and customer tier 2 if it has a standard or enterprise or premium tier subscription tier, and it also accesses the latest message from the state, and it is converting all the messages in the lower cases. And here I have given a description that if this particular user message contain any word like legal, lawyer, court, sweep, complaint, or data breach, it will be activated. So, and this will be prioritized as critical as well. And yeah, and if the tier is enterprise, then the priority will be high. Either the priority will be medium. For the enterprise tier subscription, the priority will be high or the priority will be medium. And then based on that, it will generate the ticket. So here is the system prompt that you are a Novatech escalation manager. A support ticket has already been created. Use only the following information below: ticket ID, priority, customer tier. And there are some instructions that wanted to be empathetic. Apologize naturally. Mention the ticket ID. Mention the issue has been escalated, and do not invent anything. And again, we are passing everything to the LLM, and then based on this, the LLM will generate the response. And here the temperature is 0.3. Yeah. So because we wanted the escalation agent to be bit more creative, because we wanted it to be empathetic and apologize and something like that. And then again, after completing all the tasks, it will mark it as completed and all. And at the end, it will return the message, ticket, execution plan, and completed task. Now we have a router node. So so router node basically is a conditional router function to determine the next step in an multi-agent execution plan. One more thing is that this router node is used in almost every enterprise level or industry level agentic AI project, because this is actually a right thing to do, uh, because when we have a customer query or user query, at the first place, LLM doesn't know that where we have to route it, or where we need to push this particular response to, or to which agent. That's why we define a router node which actually route it to the specific or specified agents, AI agents. So it calculates how many tasks have already been completed and tells the graph workflow exactly which task number to execute next. As you know that in the state, I have mentioned that this router next will this router agent will um, grab this execution plan, access this execution plan from the state, and it will read that if it should be routed with the retrieval agent, support agent, and escalation agent. It will also read the status and say if it is either pending or completed. If it is pending, it will route to that specific agent, and if it is completed, then it won't route, and it will only route when the status is pending. So this is a simple function that line graph can execute, and it decide what should happen next. And yeah, so this is a conditional edge. We are defining it here because we wanted to have a checkpoint in the orchestration. So that's why we created an empathy node. So, and this is what is empathy node. So as you can see in the empathy node, we have no query or anything like that, because the only task of router node is to route it to the specified agent. So here in this function, it will first uh, check the Python. As we know that Python treats completed, true as 1 and false as 0. So it will check if the status is true or false, and it will loop through every task in the dictionary inside the state of the execution plan. And uh, if it is if it is completed, I mean the task is completed, then it will return or mark it as completed and returns the number of completed tasks over here. And then we have a conditional routing edge function. So this function actually picks the exact agent that should run next by scanning for the first executed task. So let's say, so we have described the routing function over here. This will read the execution plan from this state. So, and decide what to execute next and get the execution plan from this state, then loop into the execution plan and check if any task is pending to be processed. And if pending, then it will return the string name of that agent. For example, if for example, retrieval agent. And if not pending, then it will return it to the response synthesizer. And here we have the at the end synthesizer agent. This will collect the response from the retrieval, planner, and support agent. Then it will clean it up, format it up, hide the technical details, and format a professional, polite, and warm final response for the user. So it is accessing the message, and then it is also accessing the retrieved context by which is returned by all the agents. I mean all the three agents: escalation, support, and retrieval agent. And then we give it a prompt over here. So we also passing a retrieved context. So retrieved context is basically the response generated by all the three mm, uh, agents. And then we will try to push everything to the LLM. And here the temperature is 0.3 because we wanted it to be bit creative. And then at the end, it will return a final reply or final response. So we have discussed about all the agents. Now we will move towards the orchestration. By far, I believe that in this particular project, lang graph state and graph orchestration is very important. And this is basically a foundation of this architecture. And you can also refer to the previous lecture by Priya ma'am for this specific graph orchestration. By far, I also discuss and give you a overview of that how actually the orchestration works and how actually it loops to every agent. So here we have described a workflow, which is state graph, capstone state. And then we added 6 nodes over here. So we have planner, router, support agent, retrieval agent, escalation agent, and at the end, response synthesizer. And this workflow is starting from the planner agent. So for your reference, as you can see over here, that it is starting from the planner agent, right? Now, the planner agent will route it to the router agent. So here it is routing to the router agent. Then again, now in the router agent, we wanted to have a conditional edge. Why we need a conditional edge? Because uh, after generating the response from the planner agent about the pending tasks, we wanted it to uh, route it to the specific agent that are specified in the task. So that's why we have described this add conditional edge, and this is very important. So here, as you can see that support if the support agent is required, it will route it to the support agent. If retrieval, then retrieval agent. If escalation, then escalation agent. If response synthesizer, then it will route it to the response synthesizer. So let's say if route next. So what is route next? As you can see, we have defined a function over here, which is route next function. If route next returns retrieval agent, the graph route the traffic along pointing to the retrieval agent node. right? And at the end, when all the tasks are completed, then only it will route it to the response synthesizer, right? So after support retrieval and escalation agent finishes their job, their track point right back to the router. I mean, I would say that after retrieval agent node, support agent node, and escalation agent node completed a task and all their tasks are marked as completed, then again the route next will be routed to the router edge node, and then after finding that there is no pending task, then the router next function will route it to the synthesizer node. So here what I am showing you over here too. So now as you can see, after completing the task, support agent is routing it to the router agent. So as you can see over here that, yeah, support agent is now routing it to the, again, the routing it to the router edge, right? The retrieval agent is also routing it to the router edge. And again, the escalation agent is also routing it to the router edge. And then at the end, after all the all the responses are generated by three agents and all the tasks are marked as completed. Now at the end, the response synthesizer and the router agent will route it to the response synthesizer and it will mark it as end. So this is how the orchestration is actually working. And I believe you understand the concept of orchestration over here and how the orchestration is actually working. Now I'm again also connecting it to the SQL SQLite database where we are storing all the messages that are generated by the AI agents and all the queries that is also asked by the customer in the SQL databases. So you might ask that why we are storing it into the SQL database, why we just can't have the state, lang graph state, why we can't store over there. So the thing is that once, let's say, for example, you open Chat GPT, right? You write some query, you you have some information over there, and at the end, let's say that escalation agent generated some response. And after you again wanted to visit that, again visited the Chat GPT, when you reload the website, the state will be resetted and all your messages will be vanished. That's why we created a SQL Lite database over here so that it stores the user history. As you know that in the Chat GPT, you have your chat history on the left side, right? So the same way, it will have the information about a particular user and it will label every user using the thread ID. And that is how the things will work for storing the conversation memory. Now we have created the workflow over here. I mean, we are creating a wrapper that how the things will actually work, everything together. And then we also did the evaluation with Langsmith. So this is the basic evaluation. I believe I'm not quite sure that if Priya ma'am is also explain you about the LLM evaluation. So we we are doing the evaluation here too. So what we are doing is,
We have not covered up Himakesh till so far in our episodes, but the upcoming session after this episode will talk about that. So listen this very carefully what he's talking about in the evals, because that is what we will be covering up in our next part of our episode in this series. So just explain in a detail because they might not aware about all these things now.
sure, ma'am. So what we do in the evaluation, as we know that the LLM are generating the responses, right? But how do we know that if that responses are correct or not? So for that, we do the evaluation. So for example, let's say that user inputted hello, is anyone there? And in the expected, we wanted it to route it to the only support agent, and we don't want it to route it to the either to the escalation agent or retrieval agent. So that's why we are doing the evaluation over here, because we don't want to have any confusion or any hallucination in our enterprise grade product. That's why evaluation is very important. So here the second input is what is my current subscription tier. Here we also expected it to route it to the support agent, and I need a refund for my broken monitor. Here we wanted it to route it to the retrieval agent. And how many days do I have to return an enterprise product? Here also it is expected to be routed to the retrieval agent. The same way, this query is expected to be routed to the escalation agent, and this particular query is expected to the routed to the escalation agent. So we created an example and then we tested all these 6 test cases, and I will show you the results over here. So for yeah. Oh, I'm sorry. The thing is that when that this particular evaluation is present on the quadrant website, right? And I believe because I have ran this particular code, I mean, like 15 days, it's been 15 days since I have ran this. So I believe that that link might have expired. So for your knowledge, I will tell you that it passes all the 6 evaluation. And yeah, so it passes all the 6 evaluation, and it is routing it to the expected agent. Now we again tested it with planning and routing knowledge. So here we have some query. So in that it did some reasoning. So I will show you over here the end-to-end simulation scenario. So let's say there is a question which says that hello support, and then there is a another query which says that my laptop screen keeps flickering and flashing. How do I fix it? And then in the third prompt, it says that I already tried updating the drivers and it didn't work. This is ridiculous. So as you can see that in the first response, the user is only saying that hello support. So from the basic intuition, we wanted it to route it to the support agent. So the planner agent do the reasoning. The user has initiated a support conversation with the greetings required a standard support response. So this is the reasoning done by the planner agent, and then it also created an execution plan in which only support agent is required. That's why you can see that it only prescribed a support agent over here. Then again, and then it will be routed to the support agent. Then support agent will generate some response, and then here is the response, hello again. I mean, after generating the response, it will be routed to the synthesizer agent. And then here is the response, hello again, and thank you for being an enterprise priority subscriber with Novatech. We appreciate the opportunity and all. Then again, the second question is that my laptop screen keep flickering and flashing back. How do I fix it? So over here, you can see that. So the customer asks a technical question, right? So the planner agent again do some reasoning. The user query requires technical assistance to diagnose and potentially fix a hardware issue. First, we need to look up possible cause and solution in our technical documents, then provide support to the user based on the findings. So in the planning, it made a execution plan in which it assigned retrieval agent and support agent. And as you can see over here, the execution agent is not required. That's why it only assigned retrieval agent and support agent. Then it routed to the retrieval agent, and retrieval agent searching for the knowledge base for the policies, and then give me a second. Yeah. So the support agent drafted the response. We did the vector search in the vector database, and then the support agent drafted some conversational response, and then synthesizer compiles all the cohesive final response. Then we have the response. We have this big response that you can read over here, that it contains everything: the support agent response as well as retrieval agent response, where we have a troubleshooting guide for this skin prickling um, problem. Then again, at the third prompt, we have the customer gets frustrated. Yeah, sorry, I already tried updating the driver and it didn't work. This is ridiculous. Get me a manager. So here we wanted it to route it to the escalation agent, right? And we wanted a human intervention over here. So yeah, so in the third response, you can see that after routing, after doing the planning from the planner agent, uh, it do a reasoning where it says that the user is extremely angry and demanding to speak with a manager, indicating a need of escalation. And in the planning, it it is routing it to the retrieval agent as well as support agent and to the escalation agent too, right? So for the troubleshooting, it searches for the troubleshooting driver update, and then support agent drafted some response, and escalation agent raised a ticket, and then synthesizer agent compile all the responses, and this is the responses over. So this is all about the uh, the code actually. Now I believe that. Give me a second.
So I think the code part is done. So he
Yes, ma'am.
has talked about what exactly he has built end to end. By the way, Himakesh, I just want to ask: do you have any generative AI background, or have you ever built before any project like this, or this is the very first time you have built this project?
Yeah, so this is the very first project that I have built, and for building this project, actually, for even this project, Priya ma'am taught me everything. I refer to her class. I'm actually enrolled in one of her class in which I learned everything about from Python, from basic, from beginner level Python to the Gen AI stuffs and all. Right. So
Mhm. I mean,
yeah,
I have asked this question because there are so many people who may be freshers, and they might have a FOMO fear that that maybe I will never able to write a code. And today, the project which you have showcased you eventually requires a good level of code writing, right? You have
yes,
showcased the end to end illustration on how the things are working, and the way you have explained it indicates that you have not copy pasted from somewhere. You have written on your own. You understand each and every bit of it. So any advice which you want to give to your friends who are just starting it out and doing it for the very first time, I believe, because many people are very new in this specific field of AI engineering, and they might be struggling a lot in terms of understanding, having a confidence level. I mean, they have a very low confidence कि शायद मैं कर भी पाऊंगा या नहीं, या फिर मैं कोड लिख भी अच्छे से सकता हूँ या नहीं. So any advice, any challenges that you have faced while learning, और उसमें आपको प्रॉब्लम आई और आपने किस तरीके से उसको टैकल किया, which you want to share with everyone over here on the stage?
yes.
Because
So
I
the
mean,
thing is,
you are coming from a background जहाँ पे अभी आपके बहुत सारे फ्रेंड्स उसी लेवल पे होंगे. मैं
yes,
शायद
ma'am.
उस चीज को इतना अच्छे से नहीं समझ सकती या एक्सप्लेन नहीं कर सकती या उनको आंसर्स नहीं दे सकती जो आप दे पाओगे अभी. या दैट्स व्हाई आई एम आस्किंग दिस क्वेश्चन.
So I will give you a bit of overview that the same thing is actually happening that what Priya ma'am is actually explaining. Fast forward, I believe in past 8 or 9 months, I was discussing about the same thing with my friend, and his. I was a bit worried about that. Hey, I don't know anything about the maths and all. I mean, I do know a bit about the Python coding, and I do have a lot of interest in Python, and I have already built some project on Python as well in the past. And he actually motivates me a lot, and then he told me that just start now, everything will be fine. He said that you don't need to know a lot about mathematics and all, because he is already in the field of software engineering, and he
Okay.
doesn't do any. He's not in the Gen AI stuff or AI stuff, but he
Mm-hmm.
wanted he advised me that you should go in this particular field, but because this field is booming right now, and even I have the interest in AI ML too.
Mm-hmm.
So I enrolled in your course, and then I started learning from the basics of Python, and then after learning everything Python, I mean, uh, about the statistics, mathematics, a bit of mathematics, I have problem in learning the mathematics. I mean,
Mm-hmm.
I don't understand the formula and all, but I believe
Mm-hmm.
that if you are not going in the specific research background, you don't need a, I mean, in-depth mathematics knowledge. You just need a
Yeah.
that understanding that how actually mathematics is required and why mathematics is required, and
Mm-hmm.
how the things is actually working the back end because of the mathematics, and how mathematics is working as the foundation in this every AI and ML thing. So this is what you just have to understand the basic mathematics. You don't have to
Mm-hmm.
deep dive until you are going into the research part. And this is all about the mathematics. And then one more thing that I see that in my class, that many people's doesn't wanted to build projects, and for some reason they didn't have the time to build the projects. And I believe
Mm-hmm.
that when you build a project, you will learn more than whatever you will learn in the class itself. Even
That's true.
when
Yeah.
you, yeah, and when you build a project, you will face some challenges which are not described or not taught in the class,
Hmm.
and you will do some researches by your own end, and you will come up with the solution, and then you will integrate it.
Yeah.
Look, you might see that I have integrated all these agents in one go, but this is not true. The first version looks very different. I have also showed the first version to the Priya ma'am. There is no reasoning, and nothing like routing thing was over there. um, let's say if customer asks a query in which the query should be routed to the support agent, the retrieval agent, the escalation agent, that wouldn't be possible. So in that case, Priya ma'am guided me that Himakesh, you should add a reasoning logic and routing logic over here. And using that, I built this actually. I come up with this final version. And I believe there is more to always add into this project.
Yeah.
Uh, this is all I wanted to share.
And how much time, I mean, it has taken for you, because you started from scratch, as you have mentioned, from Python programming itself. So, how much duration it has taken to reach to this specific stage where you are right now in terms of creating the Gen AI projects?
So
Eight,
if you,
9 months or more than that?
yeah, I believe only 8 9 months it took me to build this project. And I know I was a bit anxious that I wasn't sure that if I'm able to come up with these things, these skills or not at the very
Okay.
beginning. But at the end,
Hmm.
I'm very proud of myself that I learned all the stuffs and have understanding of all the libraries and Python or AI thing in depth.
Nice. I'm also proud of you. That's really amazing job. In 8 9 months,
Thank
you
you, ma'am.
also did a lot of improvement in terms of coding part, which I can visibly see over here the way you have built this entire project. Okay, going back to the project part now. So let's try to add the screen again. Maybe you was showcasing something to everyone in the backend. So can you just showcase that? What you want to showcase apart from code
Yeah.
part?
So
Let's continue that. Yeah.
so is my screen visible now?
Yes, yes, visible.
So for the backend, I have implemented the fast API, right?
Hmm.
So so in the fast API, we have multiple mm, files. So first we have main.py, which is basically a front end or the first door, which contains the main logic for everything. And then we have settings.py, which will have and will grab all the uh, important or secret information about the API and all that thing from the .env file. And then we have the then we have the state.py, which is nothing but the lang graph state, which I have described. Then we have the helper.py. This helper.py is a document translator, which customer might upload in the form of PDF or plain text. So the thing is that in the first version, there is also a feature where you can upload your PDFs and it will be converted into embeddings and stored in the vector database. But after coming up with some newer version, I believe that we don't need actually to upload customer PDF or anything like that, because they wanted to retrieve the information from the only specified customer policies. Sorry, company policies. Now we have the chat.py, which is basically a specific endpoint for front end. So it is like if the front end asks or wanted to have a chat with a multi-agent, so this will be get initiated. And when we click the, so here is a button reset chat, right? So if we click reset chat button, all the chat will be wiped out. And then we have rag service.py. So this is basically uh, yeah, so this is basically, as you can see over here, sorry, we have a retrieval agent node, right? So we have this particular, this all code bases, right? So this all the code for a specific agent I have converted into .py file. So because you can't implement everything from the notebook itself, you have to create a specific .py folder for each the agents. That's why I have created uh, files for each the agent, .py files for each the agent. So we have rack services which whose work is basically to do the retrieval and all things. And then we have graph services.py. This is basically the lang graph workflow over here, and how it maps out which agent will talks to whom next, and also looks up into the SQL database, so the system remembers the chat history even if you refresh your browser. And then we have the planner agent, right? So we already have discussed that what is the work of planner agent, and so I saved planner agent as planner.py, support agent as support.py, retrieval agent as retrieval agent.py, and respectively all the agents are saved as um, um, their respective name.py. And yeah, so we are accessing all those agents using this main.py, which is basically a inference pipeline where everything is wrapped up together in this main.py. So this is all about the fast API stuff. And yeah, so now I would like you to show you the front end of this project. So this is the front end of this project, and I have asked few questions over here, as you can see, that hi, how are you? I'm a new to Novatech and wanted to say hello. So here, as you can see, that I'm doing well. Thank you for asking. However, I noticed that our conversation already started, and I have previously engaged with you. Let's dive deep into topic at hand. What brings you here today, and how can I assist you with Novatech? So I asked another question that I'm planning to buy Novatech Pro laptop. Can you briefly tell me its main feature? So here, from this query, you can see that first we wanted the retrieval agent because we wanted to know more about the Novatech Pro laptop, and the description about this will be available in the in the uh, RAG system, right? RAG database. So it will go to the retrieval agent, and the retrieval agent will have some information from there. So this particular laptop features a high resolution display and some other specification about this particular laptop. And then there is another query, which is I purchased my NovaBook Pro 8 months ago. Is the motherboard still covered under warranty? So, so as you can see over here, from this query, we wanted to be uh, we wanted the support agent and retrieval agent uh, together, right? So this is the query which is generated by the support agent and retrieval agent, and at the end will be routed to the synthesizer agent. So we have 12 months warranty from the date of purchase. And since you had a device for 8 months, the motherboard as well as the components should still be covered under warranty if you are experiencing any issue. Happy to help with the repair or replacement process. Would you like to proceed with the warranty claim or troubleshooting issue? So here's another query which says that I have contacted with your support team 3 times, but my issue still hasn't resolved. I'm extremely frustrated and wanted the issue escalated to a senior support engineer. So this particular query should be routed to the support agent and escalation agent, and there is no need for this to be routed to the retrieval agent. So from here you can see that I understand your frustration and I apologize for your convenience. You have experienced an enterprise. So sorry, as an enterprise priority customer, you bypassed tier one support queries. I have located your ticket and then escalated it to ensure it receives the urgent attention. So this is all, and it raised a ticket over here. And again, I have um, given a query about uh, my NovaBook Pro overheats after the BIOS update. So this query must go to the retrieval agent as well as support agent. And at the end, since there is a mention that I've already contacted the support agent twice, it should also route it to the escalation agent. So in this case, all the 3 agents are activated, and the response is generated uh, by all the 3 agents, and at the end from the and the agent and at the end the response are reformulated by the synthesizer agent. So this is it, and you might think that let me check that if the server is active. I believe the server is active. I will demonstrate it with one more example. Mm, so I'm just giving a this query. Let's see. You can see over here that in the real time it is showing that what are the things happening in the background. So yeah, so here as you can see that this particular query should only be routed to the support agent and the retrieval agent. So here is the answer about this particular query. The NovaBook Pro laptop features a high resolution display, 16 hours battery and all that thing. Additionally, it has lightweight durable design. This is all, and this is how the things are working. You can also see the log in the I mean in the terminal as well. You can also see that in the execution plan, it is routing only to the retrieval agent because they wanted to know the specification about that particular laptop, and it is also routing it to the support agent for support. And the execution mode is sequential, and this is how the things are actually working in the background. You can also see that which model they are using over here, and at the end after routing it to the synthesizer agent, the final response is synthesized and it will be prompted on the UI. So this is it about the UI, and I believe you might have some question that why we are using multiple agents over here. So why we have planner agent, reasoning agent, why we only can't have one agent, and why only one agent can't do all the tasks. So the problem is here, when we have only one agent, you can't give one agent a very detailed prompt that will do all your tasks. Second thing is the confusion. If, as we know that you can only specify a single temperature to a particular LLM. So if in the case of retrieval, you can't set the temperature to zero point 0.5 or zero point 0.4. So in that case, if the temperature is 0 0.4 or 5, then in case of retrieving, the agent might rediscover some factual data by itself, and it might hallucinate. So for that cases, we describe multiple agents in the architecture and even in the industry, and we describe each agent that we wanted to be specific or pro in that professional in that particular work. So we have the planner agent. So because we wanted to plan or manage the thing, this will act as a project manager and will create a reasoning, do the reasoning, and do the I mean pending task or create the tasks for the all the mm, agents. So why reasoning? Without reasoning, the AI follows instruction but doesn't think through whether they are appropriate or not. So reasoning allows the AI to think before acting instead of blindly executing a task. It evaluates the request, considers different approaches, and choose the most suitable one. This lead to more accurate and reliable information. That's why we have reasoning, and this specific reasoning idea was given by the Priya ma'am itself. And then we have the dynamic routing. I have already explained that why we need a dynamic routing. We need a dynamic routing because we wanted that particular query to be routed to the different agents if needed. That's why we have the dynamic routing. Then we have the response synthesizer. So in the first version, I didn't have the response synthesizer. And when the query came out at the end, the when the answer came out at the end, the answer were very big and very improfessional. And that answer sounds, I believe that that answer is very raw and aren't in the proper format. So that's why I invented the response synthesizer, because different agents often produce separate output that may feel disconnected. That's why response synthesizer is working at the end. The response synthesizer combines outputs from multiple agents into one clear, coherent, and user-friendly response. It ensures that final answer feels like a single conversation instead of multiple independent replies. And this is very important. Why we have a fallback over here? So I have implemented Grok fallback over here. So the thing is that external AI services can fail because of rate limits, outrage, or API error. So this is also one of the, I would say, this is also one of the limitation I faced when I was working in this project, that most of the time it gave some error or rate limit error or API error. So for this, I have discovered that we can always use a Grok, fallback method, which is also used in industry. And the fallback, so the Grok fallback improves reliability. If the primary model is unavailable, the system automatically switches to another Grok model. So user still receives a response instead of an error. So I would also show you that where I'm using the, so in the API keys, you can see that I have using the three Grok models: Llama 3.370 billion, Llama 3.18 billion, and then Quen, Quen 32 billion, and Quen 27 billion. So these are the four models I'm using for the fallback. If one fails, it will fall to the another model. So this is how the fallback is actually working. Uh, Now, I would also like to discuss about the for future enhancement in this project. The first thing is reflection agent. We can add one more agent, which would be reflection agent. This will improve response quality before it reaches to the user. So instead of returning the first entered, oh sorry. So when I was creating this, I have already created a response synthesizer, which actually generate a improved response um, after collecting all the responses from the all three agents. Then we have the hybrid search. This is very important. I believe we have some problem in the retrieval with semantic research. So instead of just relying on the semantic search using embeddings, the system will combine semantic search with the traditional keyword search. This ensures the both contextual meaning and extract keyword matches and consider during retrieval. So this is also important, and I believe that this is use this is highly used in today in every industrial project or any industrial architecture. And then again, when we have the hybrid search, we have like two responses, one from the semantic search and one from the I mean, one from the retrieval search and one from the keyword search. Then we also have to re-rank the search result from the retrieved context. So for that, we have the re-ranker agent. Then we have the parallel agent execution. So why parallel agent execution? So right now, as you can see, I would say that if we have a query, let's say we have a query in which the I mean, the agent doesn't need to depend on different agent. For example, if we have a query and a particular response doesn't have to depend on retrieval agent or support agent, then those particular uh, agent can be executed parallelly. So that's why we have this parallel agent execution, and this will reduce the response latency. So in the current architecture, agent execute sequentially. So if we have another version, independent agent will run in parallel whenever their tasks do not depend on each other. I mean, if the task doesn't depend either on the retrieval agent or escalation agent, in that case, we can execute the uh, task parallelly. So this reduces overall response time while maintaining the same quality output quality. Sorry. And then we can also have a response evaluation layer. So this is basically for continuously evaluating system performance, which I have also showed you in the notebook itself. So over there, we were only, I mean, doing the evaluation for the first time, and we won't do any evaluation in the future response. So what we can do is we add another layer in which we will evaluate each and every response generated by all the users. So this is and we will generate a feedback based on those responses. We will rate it from 1 to 5, and then we can, after having a response from the response evaluation layer, I mean the feedback from the response evaluation layer, we can store it in the SQL database. And then another time when the user asks the query based on the retrieved state or retrieved mm, information or feedback from the SQL database, it can generate a better response next time. So this is all about the project, and I believe I have covered everything in this project. If
Thank you so
any,
much. It's a very good in-depth demonstration of the project. I was not expecting that you will cover up the Q&A part and the further enhancement part of the project as well. So I really like that last part, and I really hope others also like the same. Please do mention in the comment section for those people also who will watch the recordings of this discussion कि आप लोगों को इतना डेप्थ में समझ में आया या फिर नहीं आया आया तो कितना आया. So please do let us know, and if you have any questions now you can let us know in the chat window. By the way, this similar kind of a project we will be doing in our live cohort, which we're talking about, will start from 8th of August, and Himakesh will also be a part of that cohort, and he might be also looking on to your queries and everything. So please uh, do check it out if you are very much interested to write a code with us in the live sessions itself. We'll be happy to do with you all. So any doubts, any questions, if you have now, you can let us know in the chat window. Otherwise we can wrap up. I think already it's around 1.5 hours. We thought that we will wrap up in 1 hour, but it extended by 30 minutes more. सो अगर आपके पास कोई क्वेश्चंस हैं तो प्लीज़ चैट में लिखते जाओ, नहीं तो फिर हम इसको रैप अप करेंगे और आपके कमेंट से देखेंगे कि इफ़ यू हैव एनी क्वेश्चंस वी विल टेक इट एंड रिस्पॉन्ड बैक टू यू. Also, whatever the things he has shared he will upload in his github आपको इसके यूट्यूब के डिस्क्रिप्शन में मिल जाएगा. हिमाकेश का गिटहब प्रोफाइल, लिंक्डइन प्रोफाइल भी मिल जाएगा अगर आपको उनके पास से कनेक्ट करना है एंड उनसे कुछ क्वेरीज पूछनी है रिगार्डिंग द प्रोजेक्ट एंड एवरीथिंग. तो आप प्लीज यू कैन कनेक्ट विद हिम एंड यू कैन आस्क हिम द क्वेरीज. ही विल हेल्प यू आउट इन दैट कॉन्टेक्स्ट एज वेल. ठीक है? Any questions you have, anyone? Otherwise, we can wrap up for today. It's Sunday and we are already late. So, yeah, uh, if we are okay till so far, then we can wrap up. So this is the episode number 9 in our AI engineering playlist. And if you guys will comment and share these videos with everyone, so I will keep on coming with the upcoming episodes where now we will talk about LLM evaluations in future. I will also present one more project regarding this lang graph orchestration in my upcoming video. And after that, maybe we will start our LLM evaluations. uh, I think 3 4 episodes are pending, and after that we are finished with this AI engineering playlist. Before the cohort will start, I will try to finish this playlist first. And yeah, I think there are no questions coming up, so we can wrap up for now. Thank you so much, Himakesh, once again for joining in and sharing your work with everyone. Yeah, any last
Yeah,
words you want to say to anyone?
yeah. Thank you so much for giving this opportunity, ma'am. One more thing that if you wanted to connect or have any query regarding this project, you can always ask in the comment section. I will make sure to recheck the comment section, and I will answer if there is any query regarding this project. And you can also refer to my LinkedIn and my GitHub repository. I will upload all this on the GitHub repository. You will also have the link uh, about my website portfolio, and you can also check my website from there. And that's all. And one more thing, that I believe that there are so many professionals that are right now don't know anything about the AI. I believe my friend is also a software engineer, but he didn't know about the AI stuff, and he wanted to transition into this particular field because this particular field is booming right now. So I even suggested him the same course I am actually referring, which is by Priya ma'am, and he actually loved it, and he's currently learning from the same course. And if I believe that if any of you guys that wanted to have a transition or wanted to learn about the AI, you can always follow the same playlist, and you can also enroll in the cohort as well.
Thank you so much, Himakesh, for mentioning this. Although I have not mentioned him to say all these things, he is
Yeah,
saying from his heart.
yeah. I believe
So it's
the
not
thing is that
some paid promotion or something. It's like one to one connection, because he was there with me in the last course from the very start. It was a data science course, and we did from Python to stats to ML to DL to NLP to Gen AI, everything in that cohort.
So the thing is, ma'am, I believe that when you are in the live session now, you will actually interact with the people. You understand each
Hmm.
and everything. If you have a any doubt or query, you can ask in the same ongoing lecture. And
Hmm.
the another thing is that discipline, that you don't have discipline in the YouTube, because you know that lecture is uploaded. You have the time and you procrastinate itself. So
Hmm.
if you enrolled in a particular course now, then you know that in the brain the thing is going that we are going to have the class today and we are going to attend this. So this is the thing which actually differentiated from the YouTube itself.
Yeah, I also think the same. I mean, I also upskill myself, and for that, I also used to purchase the courses. So the only thing is ki when we purchase some course in a live mode or in a self-paced course also, we have some duration in our head. लाइव कोर्स मोर मीनिंगफुल बिकॉज वहाँ पे 1 महीना होगा, 2 महीना होगा, हमें पता है एटलीस्ट कि हाँ 6 महीने में हम इसको कंप्लीट करने वाले हैं. And we have a dedicated path. Mentor is there who will come, guide us, motivate us wherever we are feeling, wherever we
Hmm.
are feeling tired as well. तो वो एक माइंडसेट होता है कि हाँ अब क्योंकि मैंने कोर्स ज्वाइन कर लिया है तो मेरा 1 2 महीने में एटलीस्ट ये वाला काम तो हो जाएगा, ये तो मुझे समझ आ जाएगा. अगर if in case you will be consistent and you will also put your effort on योर एंड. ऐसा नहीं होगा कि सिर्फ ज्वाइन करने से कुछ होगा या फिर सिर्फ लाइव सेशंस अटेंड करने से होगा. द वे आई मीन हिमाकेश मेंशन इन द पास्ट एज वेल कि जब तक आप खुद से प्रोजेक्ट्स बिल्ड नहीं करोगे, क्योंकि उसमें जो आपको सीखने को मिलेगा वो लाइव सेशंस में भी नहीं मिलेगा. यू विल लर्न अ लॉट बियॉन्ड दैट. लाइव सेशंस आर लाइक काइंड ऑफ अ टोर्च फॉर यू, बट उसके आगे चलना आपको है. एंड आपको एक्सप्लोर करना है, बिल्ड करना है, एंड फिर इस तरीके से शोकेस करना है स्टेज पे आके, एंड आई एम ऑलवेज हैप्पी कि अगर कोई और लर्नर भी मेरा कभी चाहता है कि दे वांट टू शोकेस देयर प्रोजेक्ट, आपने कुछ ऐसा बिल्ड किया है, तो यू कैन ऑलवेज रीच आउट टू मी. आप सबको मेरी ईमेल आईडी पता है, नहीं पता तो लिंक्डइन पे जाके अबाउट सेक्शन में यू कैन ऑलवेज चेक, you can mail me out and I will happy to host you as well, and you guys can go ahead present your work. And अगर आपने मुझसे नहीं भी पढ़ा, इट्स ओके okay. अगर आपने किसी और कंटेंट क्रिएटर से पढ़ा है, खुद से बिल्ड किया है और आपको पता है उस कंटेंट के बारे में कि व्हाट एग्जैक्टली यू हैव बिल्ड, ऑलवेज आई एम हैप्पी टू टेक योर प्रोजेक्ट एंड शोकेस्ड इन द वर्ल्ड, इन टू द स्टेज, जहाँ पे सभी लर्नर्स आपस में बैठ के उस प्रोजेक्ट को देखेंगे, समझेंगे. और इसमें आई थिंक आपका भी बेनिफिट है, क्योंकि आपको सीखने को बहुत मिलता है कि कैसे हमें अपने काम को प्रेजेंट करना है. मैं हमेशा बोलती हूँ, एक होता है कि टेक्निकल स्किल्स गैदर करना और इम्प्लीमेंट करना, दैट इज वन थिंग. सेकेंड थिंग कि जो आपने करा उसको एक्सप्लेन करना एक अच्छे तरीके से. सो दीज टू आर मोस्ट इंपॉर्टेंट थिंग. आज के टाइम पे आपको हो सकता है कि कोड करने वाले बहुत सारे कोडर्स मिल जाएं, बट कौन अपने काम को उतने ही अच्छे से एक्सप्लेन भी कर सकता है, वो बहुत इंपॉर्टेंट स्किल सेट है, जो कि अभी भी सब में मुझे देखने को नहीं मिलता. सो प्लीज, इफ यू आर इंटरेस्टेड, ऑलवेज रीच आउट टू मी, डू मेल मी आउट. आई ऑलवेज रीड ऑल द मेल्स. माई फर्स्ट टास्क इन द मॉर्निंग इज टू रीड द मेल्स. तो अगर मुझे लगेगा कि कुछ इंपॉर्टेंट है, कुछ इंटरेस्टिंग है, तो I will always revert back to you. We can have Google Meet. I will help you to improvise that project, and then we can come further, just like the way we did with Himakesh as well. Okay? Okay then. Thank you so much, everyone. Thank you so much, Himakesh. Bye bye. Let's wrap up for
Thank you,
today.
everyone. Bye.